So Prime just put out a video where he talked with Casey Muratori and some other folks about different weird things with TypeScript, and it seems like Prime might have a pet peeve about this particular case here because they brought it up near the end of the video and talked about it, and we're like, why is this the way that it is? And Muratori was like, this might be a compiler error, and they were like, no, this is how TypeScript operates. Isn't this crazy? So I wanted to talk about some of the mistakes that I think TypeScript is making in this case. So if we have a string array, which the implication is this is an array where only strings can be in it, right? If I try to put something else, if I try to put something else in here, it's going to give me an error. A number can't go in there. Great. If I try to push a number onto it, it's going to give me an error. I can't push a number in there. Only strings may go in there. Okay, that's great. I'm going to make a function that accepts an array, but the array I accept in this function could have strings or numbers in it. So presumably I could do bar, and I could put a 1 in there, and I could put a number 2 in there, and it's fine, right? It accepts numbers in the array going in here. If I try null, it's going to have a problem because that's not allowed. It can only be a string or number. Okay, so far so good. We're going to push number 3 onto there, which is fine because, again, this array is allowed to be a string or a number. So we could push a number onto that array. That's fine. And then we call bar on foo. We call this function on this string array, and it's fine. It lets us do that. And then, of course, the issue here is that we're going to push a number 3 into that array. And since that's a string array, we end up with this, which by TypeScript's own rules itself is not allowed, but TypeScript's going to let us do that. And if we actually compile, I have a compiler running in the background. If we actually run this, yeah, we get a number in our string array, and the type of that array continues to be just a string array. We're not allowed to do this, and TypeScript doesn't seem to warn us. So why doesn't TypeScript warn us? Well, it seems to me like this has to do with TypeScript attempting to resolve what's a supertype and what's a subtype, and when it can infer what should be considered a subtype of something else. So in this case, string or number type here is a supertype of string array, and string array is a subtype of this. And that might seem weird. You might be like, no, string is its own type. This is like more specific. Shouldn't this be a subtype? Let's do an analogy here to make this kind of clear. If we have a type, and we're going to say animal, something very generic, all right? And then we're going to also have a type cat, very specific. And we're also going to have a type, go back, type animal. Actually, let's do cat first. Type cat. And for the sake of this, we're going to do is a string, right? And we're going to say, we could say type dog is a number. So in this case, what is animal? A cat or a dog? Right? We could keep on adding new animal types here, different specific types, string, number. Animal is any of those, which in this case, clearly cat is a subtype of animal. So string is a subtype of string or number. If we do this in this case, what we're kind of saying is that we want an array of animal here. Animal, right? And over here, we're saying basically we have an array of something like cat, right? Can't do dog because dog is numbers. We can do cat because cat is strings. All right, but we're getting like weird with our nomenclature here. So let's go back to like what would actually be accurate here is to say string array is this. That's our type. And foo is string array. Nobody come at me for my useless Vim. I'm not hopping around like I should be. I'm using Vim keystrokes within VS Code, and I'm doing a hybrid clicking thing. I'm learning, so let me learn. Okay, I'm at the place that I'm at. We have this here, which is a string or number array. So you could say string or number array is that. And fundamentally, that's what we've got here. String or number array. We've established that string or number array is the supertype. In fact, let me put this up here. It's an array of string or number. That's the super type. It's almost like you could say this inherits from that if it was a class structure in a way. And then string array is the more specific subtype. And I'm going to do the whole animal thing again later to give a better example of what this looks like to try to make it easier to understand. But we have string array where string could be considered a subtype, because string array is kind of a subtype of string or number array in this sense. On a technical level, it's not string array subtype of string or number array. It's that string would be a subtype of string or number. Let's actually do that to make that more easy. So we have string, but we're going to do string or number is this. All right. So this is what we have. String, we're going to consider a subtype of string or number. And then we have an array of that type and an array of this type. And the implication here is that the array of this type is also a subtype of the array of this type, because string is a subtype of string or number in this case. And that's the assumption that Typescript's making here, and that's where we're going wrong. And we're going to explain this in terms of a concept called covariance and contravariance, which is related to the robustness principle and the Liskov substitution principle and a bunch of other stuff. And I'm going to link a video in the description that is the best video to watch on this sort of thing. Highly, highly recommend you go watch it. It will make this whole thing make sense. But Prime's whole thing is saying like, hey, we can't push this number onto this string array. And the problem is string array is being accepted by Typescript where string or number array is expected. So why is that happening? So what's happening there is Typescript is saying, oh, string is a subtype of string or number. If we had string or number, we could accept string anywhere string or number is expected, because string is part of that, right? So if I'm expecting a number or a string and I give it a string, then that's fine. And since this is an array of using string, and since this is an array of using string or number, then I should be able to accept string array anywhere string or number array is expected, right? So here I expect a string or a number array. Here I give it a string array, so I should accept that. The problem is that that is only allowed having a type like array that uses another type like string, and here having a type array that uses another type like string or number. And having that relationship, that subtype, supertype relationship between them being allowed in this way, where you accept the supertype anywhere the subtype is, you accept the subtype anywhere the supertype is being expected, is only allowed if the relationship between these things are covariant, right? Or if the covariance is is what your operations are doing. And covariance is only allowed when you are only reading. But since we are pushing, this is contravariant, and this fails. And I'm going to go into some analogy to explain what we're talking about when we're talking about covariance and contravariance. Let's make an animal class with a name. And we can assign the name, when we create the animal, that's fine. And we're going to say all animals breathe. Right? This is very easy. All animals breathe. Probably not true. We have anaerobic animals that don't breathe, right? So for the purposes of this, we're going to say animals all breathe. We have a cat, extends animal. All cats are animals, right? But cats, specifically, meow. And that's unique to cats. And then we have dog, and dogs bark. That's unique to dogs. All right, we've got this. All dogs bark. All cats meow. All cats are animals. All dogs are animals. Cats are not dogs. Not all animals can meow, but some of them can. Not all animals can bark, but some of them can. All right, now let's do some functions. Let's have all breathe. Let's pass in an array of animals and have them all breathe. All right, we're going to loop over this array of animals, and we're going to call breathe on all of those animals. And then let's make an array of dogs. This is a dog array, right? Dog 1, dog 2. In fact, actually, let's go ahead and make our animals here. We're going to make Fido is a new dog. We're going to make Felix is a new cat. And then in this array, we can, all right, let me get my Vim stuff here. There we go. We can put Fido in there because Fido's a dog. Great. Now, can we call all breathe and pass in this dog array? Well, let's think about this for a second. We're going to loop through all the animals. Fido's the only one in there, but theoretically we could have as many dogs as we want. We're going to loop through that, and we're going to call breathe on each one. Well, is breathe going to be on every dog? Yes, it is. Because since every dog's an animal, all dogs are going to have that breathe method, which means, are we allowed to do this? I've misspelled breathe here as breath, so I'm going to be a stickler. This is fine. We can do this. Hold on, down here, didn't we just say we're not allowed to do this? Well, there's a reason that this is okay and this isn't okay, and we're going to make that clear. We can pass in dog array where animal array is expected, and it works fine. Why does it work fine? Because we're reading, in a way, we're reading from or calling a method on that array, but we aren't writing to it. All right, so what we're doing here is covariance, and in the case where we're only reading, covariance is allowed. And what is covariance? Covariance is a principle that says that when we have a type like array, okay, a generic type, if I go up here and I do array, we have a generic type of array where anything can go in there, but we're going to use a more specific type with it, like dog, right? Or animal, or anything. And that's what we're doing when we do this and we say dog and we do this brackets notation. We're saying an array of type dog, or an array of type animal. We have a type, a generic type, and we're using a type in it. What's the relationship like between arrays that use types which have a relationship with each other? Dog's a subtype of animal. So is array dog a subtype of array animal? Well, whether or not, like what establishes this relationship is covariance and contravariance. If we're doing covariance, then what we're saying is anywhere that I need an array of animals, I can give an array of dogs. Or what we're saying is that the specific type, the subtype, can be accepted when the more general type is expected. So in all breathe, we're expecting what? A general type of animal. And we're giving it a more specific type, and it is accepted. It's okay to do that, to give the more specific type when the more general type is expected. And because we can do that and that works, this is covariant, right? Contravariant actually says the opposite. Anywhere the specific type is expected, the more general type can be accepted. When this is expected, this is accepted. And you think, well, what in the world possible case could that be? That doesn't make any sense. How could I expect dogs? Because then I'm going to do something like bark on the dogs. How could you pass a general animal array into that? Wouldn't you have cats getting mixed in there? Well, yes, but contravariance only applies when you're writing, when you're doing write operations, essentially. Let's do this. We're going to add an animal. We're going to accept an animals array and an animal, and we're going to just push the animal onto the animals array, right? We have this array of dogs here with Fido in it, and I want to add a cat onto that array. Can I do that? No, of course not. I'm not allowed to do that. This array may only have dogs in it. So if I try to do add animal with dogs and Felix, hold on, it lets me do this. Even the AI autocomplete that I'm using can realize there's an error, but Typescript can't. So why is it letting me do this? Well, just a minute ago, we said that you can use the subtype anywhere that the supertype's expected, and it should be fine, right? But no, we're writing. We're writing into the array, so no, we can't do that. Now, hold on. So are you saying that arrays are contravariant or covariant? I don't get it. Array types like this are invariant. They are neither contravariant nor covariant overall, because you can only be covariant if you're reading, and you can only be contravariant if you're writing. as generic arrays that can be written to and can be read from, they're invariant. They're not one or the other entirely. Now, we can actually change this by calling one of these out as read-only. We can actually get the error to throw and show like, oh, covariance like doesn't work here. But if we pass this dogs array in and try to add Felix the cat onto that dogs array, it's going to let us do it. TypeScript's going to let us do it, even though it shouldn't, because this is contravariance and we shouldn't be allowing that. Now, here's a question. If we have a different function here, I'll add dog, and we're going to have a dogs array, and we're going to push a dog onto that dogs array, and then let's have an animals array. And in that animals array is just a cat, right? Can we pass this animals array where this dogs array is expected? And you think, no, of course not, because animals is a super type of dog. You can't put the super type in where the subtype's expected. But you can. If I do add dog and I want to push Fido onto here, TypeScript's going to throw a fit. TypeScript's going to say, you can't do that because animals, a supertype, dog's a subtype. But guess what? This is actually fine. Because think about it. We're just adding Fido onto this array. Fido is a dog, and this is fine. We're adding Fido, and we're going to end up with this. So we can add a dog to an animals array, right? In principle, that's fine. There should be nothing about this that prevents us from adding a dog onto an animals array, because if we didn't do it as a function, if we just said animals.push Fido, that's fine, because we can push a dog onto an animals array. So this is contravariance, because we can use the bigger, more general type animal when that more specific type dog is expected. And the reason this is okay is because we're writing. Now, why does this feel weird? Because as soon as we try to do something in here like dogs0.bark, we have a problem. We can't do that. Because dog0, if we pass an animal array in here, the first element is a cat, and cat doesn't have bark. We explode. We're not allowed to read anything if we're going to have contravariance. So what's the thing, like what's the deal here? TypeScript is saying, I'm going to assume that you can read and write, which is why I'm not going to let you do this. I'm going to assume that you might read and you might write, which is a good assumption to make, because there's nothing about this function add dog that tells us that we can only write to it. In fact, I don't know of anything in TypeScript that lets us do something like a write only, that we're only going to write into it. It would be kind of cool if there was, but we can do read only on animals. Now, here's the problem. TypeScript breaks here, and that's great because we're violating this contract here. We shouldn't be able to do this because this function might try to read out of it. If we can know for sure it's not going to read from that dogs array and it's only going to write to it, then contravariance is fine. It should be allowed. And if TypeScript could look at this function and know we only ever do write operations on it, TypeScript should let us do this. But when we do this one, the all breathe, and we have a cats array, right, with Felix in it, and then we do all breathe on the cats, that should be fine. Look at that. It's like the AI can hear me. It works because of covariance. That's fine. We can do this because we're only reading out. Now down here, let's get rid of all of this stuff. Down here, we have the same thing going on. String or number is a supertype, and string is a subtype. We have an array that uses the supertype and an array that uses the subtype. And then in this function, we expect that supertype. This would be animal, right? The supertype. And we pass in an array that uses the subtype, that's string. This would be like a cats array. We pass a cats array into here and we write to it. We violate covariance because we're writing, and you shouldn't be writing when you're doing covariance. If we were only reading, this would be fine. But since we're writing, the reverse is actually true. If we were accepting only a string array and a string, and we were pushing in, we could give it a generic string or number array and it would work fine. So covariance, contravariance is the reason that this is an issue. If TypeScript were to introduce something where it could detect, or it would permit you something that would let you call out what you plan on doing with that, which it does in one direction. It lets you specify read only, right? I'm gonna actually string or number array. We could say this is a read only string or number array. It'll break here, all right? So that's good. It might be more clear if we actually just do it string or number, if we do it like flat like that, right? So let's do this. And I'll have all those other types and we can see what we're doing here. So if we call out read only and we say we only plan on reading from it, then covariance is maintained, but then this is not allowed, right? So that's a great thing. Now, if we wanted to do this, to write into it, and we wanted to tell TypeScript, hey, we're going to be writing here, so don't accept arrays of a subtype, please, because we're going to be writing. We could have write only, which doesn't exist, unfortunately. It would actually kind of be awesome. And then the compiler would be able to know, I need to maintain contravariance here, which means calling bar foo shouldn't be allowed, and it would error right there, which is where it should error in this case. So yeah, please check out the video in the description from, let me get the name of this guy, Christopher Okravi. Please forgive me if I mispronounce his name. Please check out his video on covariance and contravariance. He does such an amazing job of explaining it. And I'm also going to link the very recent Primeagen video where this issue is being talked about, where Prime ran into this as a problem. I don't know. This might be a case where TypeScript really could start pushing people towards good patterns of inheritance and type safety when you run into weird cases like this. But I watched that video and I 100% identified like, hey, the reason that this is being allowed is because it's assuming covariance when that is not what is going on here. This is a contravariant situation, and we're allowing the call because if this was covariance, this would be fine. Since it's not fine. It should be erroring out right there. That's a tough thing for the compiler to know about. So maybe a write-only keyword would be great. But yeah, thanks for watching.